This conference will now be recorded.
Hi, very, hi, very good morning and good evening, everyone. Welcome back. So yesterday we're trying to talk about the storage related volumes, right? And so now, I mean, we have some more other pending things, which is basically is EFS. Okay, so if you want to use some EFS kind of thing, a shared volume. So how do you do that? And as well as PV, so physical persistent volume is what you have. Okay, so okay, let's continue that. So just go with, but I want to choose, not the single node cluster because I'm dealing with the so EFS kind of thing. I just would like to go with a multi-node cluster, and to have a multi-node cluster, the easy way you can get it is through a Kubernetes service, which is from Amazon, which is Elastic Kubernetes service. Okay, I will go with this particular one and okay, create one cluster. But basically, so there is a lot of manual steps involved. So if you want to get it in a single shot, you have some tool called as EKS-CTL. I'll go with that particular tool. So let's go with here. Let's go to the AMIs, and you know how to find out my AMI, and use that particular AMI and launch a very simple instance, which is some T2 micro. Okay, so which is comes as a free of cost. I'm just going with T3 micro because anyhow I pay basically, so either it is T2 or T3, doesn't really matter. So here I get 2 CPU, a bit faster. Okay, so configure instance details, nothing to change, add storage. So add tag name, I would say is something like so workstation or something like that. Okay. So here it is, run launch. You can proceed without keypad. So from this instance, I can deal with my Amazon by choosing a IAM role. Right? So I can go ahead and create one role. I think definitely I will be having a lot of roles. So I will find out some workstations. So I can all do is create a role, and the role is for EC2 you're creating. So just click on next permissions, and you want to attach a policy to this and go for administrator access. Okay, so just click on next tags and review. And what is the role name? I would say is a K06. Okay, so EC2 workstation role. Okay, so this has complete admin access. See this administrator access. Create a role, and this role I can attach to this particular instance. So how do I do that? So right click and instance settings, modify IAM role. So just choose that and go with this one. Just click on save. Okay, so I think I'm fine. Let's go and so SSH can go for CentOS @ the password is DevOps321. All right, so here now here all I need to do is EKS-CTL. So there is a command called as EKS-CTL, and first of all I want to check my AWS access S3 LS. Okay, so I'm able to fetch the S3 bucket. That means my role is working. My role started working. All right, so let's go with EKS-CTL. Okay, so create cluster and a hyphen name. Probably you can give something like demo and a hyphen region. So US-West-2. Okay, that's it. So it's just gonna create some cluster. Okay, how it is doing and things like that. Later we can talk about, so multi-node cluster. We also build up our own multi-node cluster. We will see that for now. Okay, so let's not get into that. Let's understand the usage concepts. Then we'll go into the admin concepts. So it just takes around 5 minutes to get the things done. So let it get done. So now in the meantime, I will go with one more connection to the same server. Okay. So let it come down and let's go with the concepts. Okay, where are we? We are actually dealing with something called as volumes. We'll come back to that. So let's move to so these nodes are okay. Anything to talk about? You require something called as Kubernetes cluster. Okay, let it come down. In the meantime, so just try to recall what we have done. Is everything been done? Yeah. So there is tokens concept which is pending. We'll talk about that. I'll show you at the time of service accounts and all. So now the volumes, yeah. Okay, so let it come down then. It just takes hardly 5 minutes to get a cluster, and you'll get a cluster. In the meantime, any questions?
So what is the difference, like if you go with EKS console and create the cluster?
You have to manually do each and every step, right? So first of all, you have to create some roles. Okay, then you have to go to EKS console and create one. First of all, you have to create one cluster, and then after creating the cluster, you have to go and add some compute manually. Okay, so all these particular steps, okay, will be done in a single shot. Before to that, you require to create some VPC. Okay, this all takes care in a single shot. So creating the VPC and everything, the tool will take care.
So this ETL you have configured manually in this particular AMI?
Yeah, it comes, yeah, I installed it, but again, the lab auto can help you if you want. If you want to install, the lab auto can help you, or it's a simple process only. Like it's a simple binary, you get it. So EKSCTL, go for GitHub, you'll find out the release. Just go there and you find out the releases on the right side. Just click on that and download this binary and keep it there. That's it. As simple as that. Yeah.
Okay. Okay. So apart from that, no other thing need to configure?
Apart from that, sorry?
Now, apart from this EKSCTL package, do we want to configure anything?
Nothing. Just EKSCTL. That's it.
Okay.
Any other questions? We have just a couple of minutes of time. Let's interact. If you have any question, could be a stupid question you can ask.
Hey, Raghu.
Yeah. Yes, Nadim.
Yeah. So when this course will end? How many days are left? I guess this
So,
month end, right?
mostly, yeah. By month end, we'll definitely complete.
Okay, okay. Just want to schedule my this one. Thanks.
Yeah. For sure, we'll try. Yeah.
Okay.
And if I go through the syllabus, so probably after volume, so some networking here, and why I kept the nodes direct. Okay, pod networking, I didn't mention did anything. Okay, so I had to talk about this. And after that, talking about nodes, namespaces, patterns. So, okay, services. So mostly it takes another week to complete these particular concepts. And so we can get onto the project. So this takes some time. So to set up the things with the things whatever we have learned until there, and then we will be going with the administration part. Okay. Yeah. All right. And if you're really looking for internals, so probably I'm not talking about the internals more. This Learn K08 is one, so website, learnk8s.io. Okay. So you can go and read some, so generally, Learn K08s. You can go here and learn, go to the blog. There are a lot of blogs actually out there. So you can start looking into reading about this. Okay. These guys write a very nice blog, by the way. Even the diagrams they put is really nice. So really, good way of, if you just some topics they go with the blogging, understanding the insights. Okay. To understand insights. See this, so making the things they do really good actually. The diagrams especially. That is one thing I would say. And also I want to do is I just want to create one EFS as well. Okay. So, but this EFS seems some changes came out, but let me quickly do with something called as I'll go with one EC2 server also. I'll go with EFS. I think I already have one EC2, which is fine. Okay. So EFS, a shared file system. All I need to do is I just need to create one EFS here. Okay. So I will just say that, it's a sample one kind of thing. And so I just want to, okay, so try with normal this one. So this also let it create. Now it came to available, it's fast only. Now I want to mount this, so then I can go here, just click on this and view details. I already shown you, right? So, but also here, previously there used to be how do you attach is something different option. Something changed these guys. Actually, click on attach, mount via DNS. Okay, let's see. So this is EFS and this is NFS, right? And let's take this one. So I would like to mount it in /mnd someplace. So it is telling that NFS4 is not found, wrong file system type. Yum installed NFS-utils. Okay. So this is the same error I was getting. FS name or service not known. Okay, I'll go with IP rather than the name. Yeah, /mnd. So it might not be working because the security group attached to that is not opening my way. Okay, I'll try to refresh. The target is fine. I'll go to monitoring.
So it's on the networking part only.
Network, I don't see a security group.
Click on manage, you'll be getting the security group.
Sorry?
Yeah.
Yeah. If you edit that, you're getting okay.
Yes.
Or are you getting? I'm not looking. Yeah, by default it's not showing. So probably settings. You can add.
It's not available.
Yeah. So if you just edit on that, it is showing you. I'll go to EC2. I'll go with the security group. So this is the one. It's just picking the default one, and I will go for inbound rules. Basically, everything is there. All TCP is there. There's nothing to add especially. So, but anyhow, I'll just add NFS. So I would choose NFS from anywhere probably. Just click on save rules. That doesn't make sense. A TFS, a TCP, that's one. It might be NFS protocol. So that might be another reason it's a blocking. Okay, now you can see df-h. df-h, it's showing MNT, it's mounted. Okay, fine. umount /MNT, and I can go for a name once again. Let's see. It is working. Okay, just took some time. Okay, which is fine. Okay, this is what I'm looking. umount /MNT. But I'll delete this because where is this? Let's go. I'll delete it because the other one which I want, the one I want to make it is basically has to be in the other subnet, other VPC. So because the cluster comes in a different new VPC altogether. Okay, that's the reason. I would create another one. So create file system, and create file system is I will say that so PV storage for EFS. Okay, and enable automatic backups. I don't want it. Let it be. Anyhow, we'll delete it sooner. So here is fine. Okay, click on next, and here you have VPC selection. So now I'll go for this EKS one. You select that, and you're getting one security group. Okay, so fine. So just click on next, and you want to change anything here. Next, click on create. Done. Now I'll go to the security groups here. So this is the one, and go for edit inbound rules. I will say NFS from anywhere. Just click on save rules. Yeah, I think we're fine. So it is still deploying up. Almost, yeah, done. Cluster is done. It is actually trying to deploy the nodes. It's going to create 2 nodes automatically. So of T2 medium size. Let it come. Node group is creating.
So where we have defined the number of nodes, like 2 nodes?
Yeah, you can actually, that's default. Default. You can go for EKSCTL -hell. If you don't specify anything, it goes with minimum 2 nodes. EKSCTL create -hell. So create cluster -hell. So yeah. Yeah. So the minimum nodes and maximum nodes by default is actually 2. Default is 2.
Okay,
Yeah,
got it.
You can change that all the time. So from tomorrow onwards, basically before session, I'll just create this EKSCTL and we'll get everything ready. Okay, get it ready so that we'll not have much time waste. Okay, so here it is not showing yet. No node groups. It might have created auto scaling group, but node group it is telling auto scaling group. Yeah, but on the node group also it should be showing. Okay, so let it be. So now you got your cluster ready. So now what you can do is you can just execute kubectl command. Kubectl get space pods. You will not see anything. Ultimately, you should not get any error. It is saying that no resources found. And I go for go space node, get space nodes. You can see that there are 2 nodes actually coming up. Previously, you're running everything on the same node. So now actually you're getting 2 nodes from this. Now you can start playing with these things. Now let's go back with the persistent volume. Okay, yesterday we have seen storage class. How do you deal with your own storage class and things like that? So today we are going to go with a persistent volume. Okay, create a persistent volume of your size, and you create your PVC. Okay, from that particular persistent volume. So create persistent volume Kubernetes. So EBS. If you just go for there and AWS. This claim. Yeah. So this is how, like yesterday, however you created yesterday, however we created a direct direct storage volume we created right yesterday. So what we had created, let's cross check. Yesterday we're trying to go with the host path. No, not host path, EBS direct. So you're actually using the EBS direct directly, right? So rather than this, what you're going to do is you can go with rather than this, you can go with creating a PV and create a sub volume inside that PVC, and you can use that in the container. Okay, so how do you do that? So, and then we'll talk about some relation here. Okay, so now you just go here, PV and sorry, new file. So pv.yml. So now first of all, what I'm going to do is I'm going to create one PV, and using this PV, I'm going to create one PVC. Okay, so how do you create PVC? So probably storage class can help you in creating how do you create PVCs. So this is what you create, a PVC. Okay, and the pod you're going to use is the pod. Yeah, let's modify this. Now you're going to say that, so persistent volume. So like, let's say I want to go for AWS PV, that's fine. The labels is okay. The size is like, let's say I give 5 GB, and it's actually giving as read write once. So because the EBS volume, you can only write it once. That means only one pod can read and write that. Okay, so others cannot access it. So, and your volume ID, all you need to do is you need to create one volume, right? Already you need to create one volume, and you have to use that. So let's go to the EC2, and I will see it as, then if I'm already creating, then what is the point in giving the storage? Okay, let's see. Go to the volumes. So create a volume, and so probably like, let's say 3 GB or 5 GB you're saying, and yeah, the STA is fine, and is not needed. So just click on create a volume. And you got one volume ID. And you're saying that I want is XFS volume, okay? And so this is 5 GB, whatever you have created, you're just mentioning that particular size. Or without capacity, can I create it, is what I'm thinking. Let's see if it throws an error, we'll look into that. So I will just comment this, push the code. So here space pull, so cd storage qcdl -f pv.yml required value. Okay, fine. So here so I push the changes. Let's do the pull. Yeah, so kubectl apply -f and then pv.yml. So you created one PV. So let's search for PV in the top. Now you are getting one PV. That is fine. Now I want to create a PVC for this. Okay, so that means I'm just going to uncomment this. And now there is no more storage class. I want to use persistent volume, right? So how do I do that? So let's see a bit more documentation. So persistent volume claim, and so here is how you do that. Okay. So here you're saying so it is telling this guy didn't give syntax properly. Okay. So now what you're saying is I want some, okay. So now this is a big chunk of volume. Okay. So generally we create one PV, and out of that, so wherever you want, you're actually going to create some small chunks of the usable size, and you do that. So this is maintained by the administrator, and he will bring this particular PV available. So what you're saying is I want this particular size, and you're claiming this volume, and you're going to consume that. Okay. So that's what you're going to do. All right. So let's get space full and serial apply hyphen this one. You created a PVC now, so go and search for PVC, and the PVC is pending. Why it is pending? Why? Because it's not been consumed. Okay. Now what you're going to do is you're just going to say that this is actually AWS PVC. So this is AWS PVC, and claim one, everything is fine. Now create a pod as well. Apply. Now go for pods, and now the pod is actually going to create this. Also, you can give pods comma PVC, both you can search at the same time, right? So pods, and it's actually going to pending state. So describe this, and what it is doing is it is actually provisioning some volume. Okay. Now failed to bind volumes. No, provisioning failed for PVC. First, let's go for PVC. So PVC, why it is actually pending? Let's describe this and look some messages here. Failed to provision volume, storage class GP2 is not supported. Why it is actually taking storage class? Do we have anywhere storage class? No. That's what I'm wondering. So you would be saying somewhere this is my persistent volume. This is okay. Existing PV. So here it is host path. Rather than that, you can just choose. We already chosen that one, which is fine. And create a persistent volume claim, and the storage class name I would choose it as manual. But manual, is it created? So if you're a customer, if you're a cluster administrator, so create a persistent volume backed by some physical storage. You do not associate the volume to any part, so that's okay. Now you're taking the role of a developer. Just create a persistent volume claim that is automatically bound to suitable persistent volume, and you create a pod for claiming it. That's fine. But what I'm thinking here is, will you get the manual? How do you get the storage class name, which is manual? So because if I go for SC, so you get only GP2, you don't have manual. Or if you give this particular keyword, will it take? Let me give a try. So kubectl delete -f pv.yml. Okay, so now let's do some modifications. Okay, let's go with PV. Is it going to throw an error or? So PV is created, describe, and we got something. Okay, fine. Now I'll go with the PVC, and in the PVC you're telling that. So you want to create some storage. Persistent volume claim. What do you say that as? Claim 1. Storage class is manual and resources request is, so probably 1 GB. Now let's see. Now you will get an error, is what I'm believing. Okay, PVC. So PVC claim 1 also came out. Okay, from the volume AWS PV. This is important. Yes. Now you got it. Okay. So from the volume of AWS PV, now you got, so now you got what is the capacity we asked for? 1 GB. So now you're going to get 1 GB. So let's go for describe. And okay, so you got it. So let's see. And the next one is going to be is just take this one, and your persistent volume name is claim 1. Give me 1 minute. All right. So now let's go and try to create a pod as well now. So now the container is created. It's actually what it is doing is attachment failed. Okay, AWS PV error attaching the volume. Okay, because the availability zone mismatch. The volume is not in the same zone where your nodes are available. Okay, so let's cross check this once. Let's go with this and go with the instances, or we're already having a couple of this one. So this is 2A, and the two nodes which you have is one is in 2C and 2D. Okay, it will not work. So delete it and change the volume. Okay, so let's delete the volume. Let's create the volume. Go for 2B. To check once again. It is available is one is 2C and 2D, not even 2B, 2C and 2D. So create a volume. It actually comes under 2C and 2D. Okay, create a volume, and this is the volume, right? So just go and update this now. So technically, I mean, if you are working in a very legacy organization, so how it works is, this persistent volume works is you're going to have, so your own servers, So back in days, how do we attach the storage to the servers? So we mount, we attach that particular disk to here. We attach that particular disk to this particular server. Okay, and the storage will be there. So this is the typical infra. Okay, if you're not in a cloud, you're going to maintain your own nodes in your own data center. So this is the node. So these nodes are actually going to mount it in some directory /mnt or something, or /mt or whatever it is. Some directory you mount it, and or you make the disk available. So from there, if you're already mounted, you can just choose this. Okay, so that's where some depends upon the storage, you have to choose it. Now what I'm doing is I'm actually having some volume available because I'm using cloud. I'm just using this approach. Okay, so this much. So now let's go with describe this. So now it is actually trying to successfully attach the volume. It automatically get attached to the node, and it came to the running and go to the logs, nothing, go to the shell, and you just go and give df-h, df-h. Now you can see that particular size is getting mounted. Now, but what I'm seeing here is I'm requesting for 1 GB storage, but how come I am getting the complete, the volume is what I'm thinking. So I'm also quite not sure on this. Why? Because that also depends upon this one. Okay, so how much you have to claim and all. So because since this is the volume, you cannot cut into pieces, might be. That also, I'm not sure. Need some theory reading here. Okay, so but also, I mean, you understood the point, right? So actually, the PV is actually going to be a big chunk, and the PVC is actually going to be a small chunk, and you'll be using that way, right? So that's what is the general idea. But here, you're getting something else. Okay, let me do one more thing. So cd/data. Okay, so dd create 1 GB file. You can create a dummy files there. Okay, so by using some command called as dd, by using a dd command, you can create some files, and you can test the sizes basically. Okay, dd is equal to 0, output is equal to this one. Yeah, this is the here. Create 1 GB file. One G, 2G, and df-h. So it is saying that it is actually consumed only. No, it's not clearing the files properly. It says 1 GB file, but the disk is not actually being consumed properly. So whether are we using 0? It's 0 only. This is the right approach. Okay, df-h. Now it consumed the size, right? So now let's create one more file, and it's gonna be 2g.bin. This file is also working. So this also I need to have a cross check. I'm suspecting this is because of that particular volume type, physical volume type, which are using AWS. So because even if you come out and see that the PVC also, the PVC, even though you're saying the size as go with 1 GB, you are still getting 2 GB. Okay, so that's where I feel something wrong here. PVC. So let this PVC go away, and let's. I'm curious a little bit. Yeah, PVC, that's gone, right? So you created this, For this PVC, when I create together, you're getting it. So this is something tricky. Okay. Now, need to take a look on this. I'm still not convinced actually with this solution, whatever I'm seeing here. Why? Because so what this guy is actually doing is he's putting in /mnt/data. Okay, so some data he's putting, and he's claiming and he's taking 10 GB, and out of that he requests 3 GB storage from that. So I mean the major problem coming up with this storage type. Okay, the PV storage type is the problem. Okay, so because that is something is actually happening there. Okay, I'm also not quite getting the internally what it is happening. If we try this particular one, okay, let's go with this approach. Let's go with creating a persistent volume with, let's go with a persistent volume with the NFS, EFS. Okay, so that we will come to know. Okay, so this particular approach. So what I would do is I will go for EFS storage. So PV Kubernetes. Amazon EFS. This is too much. I don't want this. So you can just go with this one. Let's try this much. Yeah. So it is actually EFS, which is okay, and the storage is, let's say, 10 GB, and the EFS ID. EFS ID is you can get it from here. So go to the EFS, right? Here it is. Just take that and put it to here. Okay, the path is this one, and you claim 10 GB. Okay, first thing. Let's see how it goes. So go with PV. You see it as 10 GB. Okay, fine. Now what next part? The next part is you're saying that, so out of from that you want to create a PVC. So persistent volume claim and is also EFS persist. Okay, which is fine. And out of this, I want to make 1 GB out of this. Okay. Storage class name he is putting as empty. Okay. So, and it is EFS persist. And just here. And so now go with PVC. So it automatically bounded that. And here also you're getting the capacity as 10 GB. So EFS also will be something. I mean, this cloud is actually masking the things. That is the problem. We would say. So unless until we set up our own, manual cluster, and so this PVC concept cannot be shown properly. Making a little bit sense. Anyhow, I will take a look of that. But for now, we'll just proceed with this. And let's go with the node. Make a note so that I'll not forget. Now this is actually calling it as this persist. So shall go with df-h. So this size is completely anyhow is going to show you the EFS related size. So previously also when you just try to mount this on the system, you might have seen that. Okay, so it might have shown you the size. Actually it shows is so the total NFS problem. NFS will always try to show you the total size. Okay, so since even though you have a limitation, but it will show you the complete size. So that's what you have. And now let's go and try to create some file. So cd/data, let's do this. Now it is slow if you observe, okay, because it's a network file system. Previously it was a direct attached disk, okay, it was faster. So now df-h is not showing anything properly. So -lh. You can create the files, but at the max of 10 GB, I believe, if I'm not wrong. So we'll go with so count these files, something like that. So that's okay. Okay, so now you need to understand one concept here. Okay, so what is the concept is I would like to run this particular one. Okay, so here it is, storage class name. Probably storage class name. You created your own storage class, right? Yesterday. Yeah, fine. So now if I just go to ls kubectl, kubectl apply hyphen f, apply hyphen f, apply hyphen f, storage cluster. So there is already a pod with the same name. So this is getting created, right? So now let's talk about some concept here. Okay. So what is the concept we wanted to talk about here is 10 GB file. That's fine. So now the concept which we want to talk about is, so actually what is the diagram which I mentioned yesterday? So there is two things which is called as PV and SE. Okay, you create a PVC. Okay, and then so you create it from PV or you create from storage class. This is what we talked about, right? But actually that is not completely true. Okay, so what actually really happens in the backend is when you try storage class is a simple driver. Storage class is always a driver. If you want a persistent volume claim, you should always have a persistent volume. Okay, so since that is the reason, so now actually we created PVC. Now I created claim one. So this is the one, and this is actually showing the volume, this one, right? So if you go to the PV, now automatically the PV also come. You see this? This is the PV. Okay, this is the PV. Okay, so without a PV you will not have PVC. Okay, now what is the storage class is doing? Storage class is a driver, just a driver. Okay, it creates it's just a driver. It's just a driver. It creates a PV and then creates a PVC on top of that. Okay, so that is how the things will happen in the backend. Okay, so now yesterday diagram, if you try to recall, so the PVC, I can bring the diagram. Okay. Where did I note that? Yeah. Now you see here, you get a persistent volume claim either from the PV or from the storage class. But this is not true. So then additionally, what's going to happen here is the storage class will provision a PV here, and then you get the PVC from that. Okay, so this is what is actually going to happen. Okay, and yeah. So and another quite important thing. So I created this EFS for another reason to talk about. So what is the reason I wanted to talk about here is, so I wanted to show you something. This is basically read write. This EFS actually is, if you just go for describe, and there is a type, actually you make it, it's read write once, or you will get it on the PVC. So go for PVC and go for this one. So you will get read write once or read write. You go with read write once or you go with read write multi. This, yeah, if you just go for RWO, okay, read write once, and whereas you go see here, it's actually RWX. So what is the difference between that? Okay, and RWO versus RWX. Okay, so Kubernetes, this one, just go with that. Okay, RWX. This is the one. So read write once, read only many, and read write many. Okay. So now the storage EFS can be parallelly accessible. Not only a single node, you can access it on the multiple nodes at the same time. You can do that. You can access it on the multiple nodes, and you can still read that particular data. Okay. So what I wanted to show here is okay. So this particular PV. Now let me go and create one more pod. Okay, so as 2 I call it as. I'm just using the same storage. Let's push this. Where did I add P1 in it? Yeah, now you added one more pod. So now you see this pod-sc is on one node, and pod-sc2 is also on the same another node. No, on the same node. Now I need to create one more. So so that I will, until the pod get created automatically on another node, I will just run this. Okay. All I want is a new node has to be picked up. So when the new node will be picked up automatically, if this server is exhausted, then it automatically put that. Okay. So then one more, it's not going right. So one more, and I will say this as 4, and I would choose some resources. So if I go for some resources, and it automatically will put some node there. So CPU, I would say that so our memory, right? Memory, and I am choosing so 20, like let's say, right, so some 3000 MI. Okay, I would say this much. Now definitely this much capacity is not available on that node because already some ports are already running there, and it might go with the other node is what I'm expecting. So now you see this, it is picking up the other node 179. Now all you need to understand is that these pods are on one node and the storage is already there. And you go to the any pod, you go to the any pod and do shell, like let's say, and you go for df-h, the data will be there. So you go into the data, you see the data. So cd/data, okay, ls-lh, and you will see that particular file, 10 GB file. Okay, so you're creating that, right? Now you go to the another node also, the pod on another node, you can just go here and you can go to the shell now. So now df-h, so here also you'll find out the data, and do ls-lh, and you can see this. And also you can do is you can parallelly read and write the data as well. So touch sample.txt file and come back here. You're in pod 4. Let's go to the pod 3. So ls/data. Okay, automatically you'll see the sample.txt. That's the difference. Okay. So now depends upon the storage. Okay, you have to choose whether you'll be getting read write once or read write many. Okay. So yeah, that's how you deal with that. That's how you deal with that, right? So yeah. Fine. That would be the things on the storage side, but I'll check that particular PV. Okay, I will try to simulate what I'm talking about. So, and then we will get into it. I'll show you that. Any questions?
Yes, sir, I got a basic doubt here. So,
Yeah.
the nodes, what configuration do you take?
So come again. What is that?
Instance side.
Your voice is breaking.
No, which type these nodes will get launched? Because we
So
have.
by default, we are in T3 medium.
So how to change it?
You can change all with ekctl command.
Okay.
Okay, so you're getting instance name, instance prefix, instance node private something. Okay, so AMI no type. By default, you're getting M5 large, not T3 medium. Sorry, M5 large you're getting. Yeah, you can change that by the way.
Okay. Okay.
Minute. Any other questions? Or did I confuse too much? Okay, cool. So the next topic is actually we get a little bit so we'll get a little bit into the networking part. So let's see this. Okay, so the next thing is going to be some pod networking. Okay, so let's try to understand how a pod-to-pod communication will happen. Okay, so pod-to-pod communication will happen. I thought in that particular point I mentioned pod networking, or immediately the services is also there. Yeah, so let's do some introduction to that and we can move on. So here, if I want, I have some pods here, right? So I have some pods, and how this particular pod-to-pod communication will happen. Okay, so now this is on one node, this is on one node, this is another node, right? So how this particular communication will happen. Okay, so you need to understand that. So let's go and try to talk about that with simple diagram. Okay, so let me just bring the iPad. So yeah. All right. So now let's try to understand this. So previously you're having one single node. Okay. So you're having a single node, which is fine. Okay. And you have two containers. Okay. So C1, C2, N1, node 1. Now how the communication was happening? Okay. How the communication is happening? So you have a network as well. You have a network device. Network interface, we call it as. Okay, network interface. So now how this earlier you have a container to container communication is happening. So how can we do that? So if you use same namespace network, if you use not namespace, if you use the same network space, so you can directly communicate. We have so talked about that, right? So that is fine. But actually, if you don't have that, so directly the two containers, how it communicates is, so there is some network which is created, so which is called as some bridge network. Okay, so some network, that container will create. Now the traffic from C1 which comes to this virtual network, okay, so goes here, and from here it reaches to container 2. This is how it happens. Okay, because both are in the same machine, okay, which is fine. Now you're actually exposing the port to the outside world, right? -p publish, and you can do that. So that means what it is doing is it's actually doing some natting here. So the IP address of this one is being natted to here, and it's actually opening on this one, and finally you're able to access from the outside world. Okay, this is happening. Natting. What is natting? Network address translation, right? So one IP to another IP translation. So like let's say if I look my IP address of my internet, I'll have a Wi-Fi router. So with Wi-Fi router, okay, I can attach multiple devices behind it, okay, inside it. So how can you do that? Because your Wi-Fi router is a natting device. Okay, it has a capability of doing that. Now it's actually the public IP comes to the Wi-Fi router is something, but your internal IPs is something like 192 something series. So the translation will happen. Okay, so the same way, so your container is actually going to have one IP address, and your network is going to, your actual server is going to have one IP address. Or else this natting concept is basically you have a public IP address to the server, and you have a private IP address of the server. You hit the public IP, you're reaching the private IP, right? So that layer is called as natting. Okay, so here also the same thing happens. It actually doing the natting, and you're able to do that. Now the thing is, a new node comes into picture. So now a new node comes into picture. So now how the communication will happen? C3, C4, and 2. Now I want to communicate between the other network, other node, other network. So they're also the same story. So you're going to have network, you will be having bridge. Okay, so now these two network interfaces is communicated. It's been communicated. Now this is how, so any if any container actually want to talk to, let's say this container 1 want to talk to a container which is on the other network. So then what we are going to have is this container will come to this bridge, and and actually it comes from here, it goes to here, comes here, it goes to here, it comes here, it comes here, it goes here, and it goes here, and it finally reaches here. Like let's say if it want to communicate, so this is how the place step by step it goes. Step by step it goes. Okay, so that's how you're going to it's going to communicate. But the very important point actually here is very important point here is, so this actually server IP address is something like, let's say 192.168.192.168. Now let's say some 0 dot, okay, so 10. This is 192.168.0.11. Two machines I have, two networks. And what is the container IP you get? You see the container IPs all the time. You'll see 172.172.x.x.x you get here, or let's say you put it like 172.31. Okay. Now this network is actually going to be. Let me switch to the. Let me switch the network to the. But do I have? Yeah, I think. So if I go for this one, sudo, if I go to the system, sudo su hyphen, okay. Now if I go for IP space -a, IP space -a, and you're going to have 172.17.0.1 by 16. This is the default network you get it. Okay, so 172. 17.0.0 by 16 is the network range you're getting. Okay, now here also this Docker container also will get the same network range. So 172.17.0.0 by 16. Now try to understand this particular point. Okay, so this whole Docker range you're getting is 172.17 series. Now this IP address is now 172.17.0.1. Okay, or let's say 2, and this actually 172.17.0.3 and 172 dot, just assume, okay, it's not, may not be real, so 0.4. So but actually, so here also you might be having this as 2, and this comes as 172.17.0.4. This is the important point actually. So the same IP is available on the second node as well, right? Because it's an individual virtual layer. Every Docker container comes up with its own virtual layer. Okay, so you will not have a separate IP address ranges there. Okay, so is that point clear? Okay, this is a very important point, by the way. So is there any confusion there? How two nodes are there? So two nodes, physical nodes, are actually having a different IP address, which is fine. Virtual machines or physical machines you have, but inside operating system, something again virtual layer is there, which is Docker. Those are two machines, and it has its own Docker, and so the network ranges is always same, and you get that. Okay, so is that clear? Any questions on that? All good? Okay, cool. Now the challenge comes into picture. So how this container now goes and reaches there? Is it possible? No. The network scope is always here only. Just dies here. It cannot actually go here. Then how can you communicate? The question, how can you do that? And that is where something called as overlay network comes into picture. Okay, overlay. Okay, network overlay comes into picture in Docker. Okay, so now using this particular overlay concept. Okay, now this overlay will take care of, overlay is a part of orchestration. Overlay is a part of orchestration. Okay, so it's a part of orchestration. Now orchestration will play with that. Okay, now this node, some network range it will try to keep, and this node it will try to keep some network range. This node it will try to put one network range, and the other node it will try to put another range. Okay, so that's how it's gonna happen. Okay, so now overlay networks. Let's try to so show you. I'll try to show you one diagram around the internet, and then I'll try to show you how Kubernetes is actually doing this. Okay, fine. And how pod-to-pod communication will happen. Now you'll understand. Yeah. So Docker overlay network, if you try to understand, let's go to the images. So node-to-node communication. Okay, so yeah, you see this, it separate maintain a virtual network layer. Okay, so to this particular one. Okay, so that's how it's gonna happen. All right, that's how it's going to happen. Overlay network, and this overlay network is actually managed by so a cluster manager, which is orchestration tool. In our case, it's Kubernetes. Okay, Kubernetes is managing that. Now if you just go with this, you will understand that. So then what actually this overlay is going to do is, now what overlay actually brings up here is, overlay is actually going to bring a separate network. Okay, what overlay brings here is overlay brings, so like let's say, so if you take 172 series only, like let's say an IP address, if you take, so 172 dot, so 0.0.0 by 16 to this particular network range, and here it comes to here, it actually brings the bridge network as 172 dot 1.0.0 by 16. Like this, it's actually bringing the overlay is actually going to bring. So the overlay brings a separate network for each and every machine which is getting added. So that's how now the translation can happen. Now the network can happen. Okay, so and this, okay, have the information about the routes where it can reach from 172.0 to 172.1. So this overlay will have a have an information about the route. How can it reach to that network to here? Okay, so the overlay is a concept, right? So now let's go and how Kubernetes is actually doing is each and every node, the Kubernetes also does the use the overlay part, and now you see this. So now all these particular parts are actually a part of all these particular nodes are actually a part of or these particular parts is actually a part of one particular node, but you have another one here. But why are we getting a separate network ranges here? It is maintaining, I think. Let's try to see here something from here. Okay, it is putting two private IP ranges. Okay, 172.168.51. 39.42. No, this is actually doing something else. I can show you this in setting up our own cluster, or probably coming to the networking part. Yeah. Now you see this. This guy is actually doing something. Okay, he added so many network ranges for this particular system. So 192.168.45, 192.168.63. So many IP addresses is actually putting, and also those are coming from particular range. Okay, this is a little extra information. So what I just told is you just keep it in mind, and tomorrow I'll try to probably show you that. I can start with from there. I'll get one cluster created, and from that cluster I'll try to show you. Okay, so one pod, how we are getting that, another pod, how are you getting that, and this guy is actually doing something more. Okay, so we can understand this bit later, but at this point of time I just want to talk about how a pod to pod communication is happening. Now pod is a wrapper on top of container, right? So now you could just replace that C1, whatever you have seen in the diagram, as P1. That means pod 1. Okay, now pod 1, how it communicates to another pod is still the overlay network. Okay, and every node, each and every node, you're going to get one overlay network, and you can reach with this particular IP address. So now pod to pod communication, now this pod, let's say pod SC3 want to talk to pod SC1, okay, it can talk to its IP address even though it is on another node. Or let's say pod SC4 is on another node, it can talk to any other so pods of other node, so by hitting that particular IP address, because of something called as overlay network. Okay, so this is how the things will happen. But pod to pod, so if I just, let's say, if I kill any of the pod, okay, like let's say pod SC I killed, and pod SC1 I killed, pod SC2 I killed, so the IP changes. Pod SC3 also I killed. Now let's say if I go and try to apply this, so apply BB, so you get a lot of pods again getting created, so the IPs will change once again. The IPs will change. The IPs always change, so you cannot rely on the IP. So that's where the cluster comes up with some naming, so DNS concept that probably you'll see in the networking part. So, but at this point of time, I just want to show you how a pod to pod communication will happen. Okay, so from there, so probably we can get into tomorrow with the other topics, which is starts with some nodes, multi nodes. Okay, so how do you deal with that? So we'll see in tomorrow's session. What is this? Why do you need this? So the concept, start. Yeah. All right, I think that's all from my side. Any questions?
So this is only on orchestration level, Raghu?
Overlay is only on orchestration. Yeah, without orchestration, you cannot play with overlay.
But still in Docker, we are using the overlay, right?
Yeah, Docker Swarm. There is also an orchestration layer, Docker Swarm.
Okay, okay. So no, that's what like I'm asking. Without orchestration, we won't use this overlay.
You require someone who manages that.
Okay, okay. Okay, fine.
Any questions? Okay, all right. If no questions, we'll meet in tomorrow's session. So for tomorrow starts with, I will just bring one more cluster. I'll show you that how overlay is actually working, and what actually Amazon is doing. So why actually Amazon came up with something like that way. We can try to understand the architecture a little bit later in the so the administration part. Okay. So when you set up your own cluster, what are the things to consider? Okay. So at that point of time, network is one component, and at that point of time, we'll talk about that. Okay. All right. So any other questions?
So tomorrow we are going to configure our own cluster, right? Not the EKS, but.
No. This one only will use, but I will show you that overlay with a plain cluster. I'll just bring one more cluster and I'll show you how it is actually on the plain one. Yeah.
Okay. Okay, fine.
Okay, all right. So let's see in tomorrow's session then. Okay, thank you. See you tomorrow. Bye. Good day. Good night.